welcome to the next lesson, which is on reflection. So by the end of this small unit of the topic, you should be able to do the following. Understand that light waves are transverse waves which can be reflected, refracted, and diffracted. Use the law of reflection, which is the angle of incidence equals the angle of reflection, and also use it to construct ray diagrams to illustrate the formation of a virtual image in the plane mirror. So before we do that, let's just summarize what we've done in previous lessons with reflection and refraction. So both water and sound reflect and refract. Okay, so you can see in the animations where reflection is, of course, the bouncing of the wave off a surface, and also refraction, which is the bending of a wave dependent on the density of the mediums that the light is going through. And of course, diffraction is the bending of the waves as well, and we've now learned that the narrower the gap, the more this diffraction is seen to increase. The bending is larger. So now let's look at the reflection in a plane mirror. So if we have a plane mirror, we put it down on the surface and place a normal line 90 degrees to the plane mirror. Then if we have an incident ray hitting the plane mirror, it's going to reflect, obviously, and the angle of incidence, okay, the angle of the incident ray to the normal will equal the angle of reflection, the angle of the reflected ray to the normal. Okay, and also to remind you, always use a ruler to draw light rays, okay, and don't forget to include arrows to incorporate the direction of the light. The law of reflection, therefore, is the angle of incidence will always equal the angle of reflection. And the incident ray and reflected ray and the normal all lie above the same plane. Okay, so these basically you can draw it all on a flat sheet of paper. So, where does the image form in a plane mirror? Well, here we have a wonderful light bulb. Okay, so if you draw a ray to the plane mirror, it will reflect off at a equal angle. Okay, so it can be seen by the line, by the eyes, and what we have is the image of in the mirror looks the same as the object, but it is laterally inverted or back to front. Okay, it's also the same distance. And the image form is also upright, but is known as a virtual image. It doesn't really exist. So if I went to the back of the mirror of the picture of the kitten, there'll be no kitten at the back of the mirror. Okay, so with that in mind, now try and predict where the virtual image will form in the plane mirror. Okay, that blue line, why does it form there? Okay, so you should have got an answer similar to this. Okay, so the light rays are 2 points. They hit the normal line, bounce off. Okay, angle of incidence equals angle of reflection, and therefore you can move the virtual lines back from the plane mirror to find the positions on the x and y axes of the 2 points. Join them up to give you the arrow. Okay, so the image will be the same distance behind the mirror as the object in front of it. It'll be upright, the same size of the object, laterally inverted, and also virtual. Okay, where is the image here in the plane mirror? Okay, this is the normal view from the front, okay, of the ambulance, and the same view is seen in the rear view mirror of the car. So the word ambulance has been laterally inverted. Okay, so it reads correctly if you're looking at it from the driving mirror in your car. Okay, where is the image in the plane mirror? What you do is you put a mirror upright on a piece of paper, put a pin in front of the mirror, and mark the position of the pin on the mirror. Okay, you'll line up one edge of the ruler with the image of the pin and draw a line to mark the position, and do the same on the other side. So you will have 2 points finding the dot, and take away the mirror, and the 2 lines meet will be the position of the virtual image. Okay, you can test the position by putting the second pin exactly where the image was marked. the second pin should line up with that mirror image wherever you view it from. Okay, there's no parallax error. Okay, and the rules for mirror images are the same size as the object. The image is far behind the mirror as the object as it is in front.